Two questions that chemists often ask are how much do I need and how much can I make? You might have seen the following saying on a t-shirt or someplace else: chemistry is just like cooking, just don't lick the spoon. And this is true in very many respects. Just like when I want to make a sandwich, I might ask myself, how much turkey do I need? How many slices of bread do I need? How many tomatoes should I have? How much lettuce do I need? How much cheese do I need? On the other hand, I might look in my pantry and say, oh, I have about 10 tomato slices and 6 slices of bread and 3 slices of turkey and 4 lettuce leaves and 5 slices of cheese. How many sandwiches can I make? These are the types of questions that we can ask about any chemical reaction, where the chemical reaction is a recipe for making a particular compound. Just like the recipe for making this sandwich is 2 pieces of bread, 2 lettuce leaves, a slice of turkey, a slice of cheese, and 2 tomatoes. Let's see how this analogy works with this chemical reaction. So this chemical reaction gives me a recipe, 1 sodium carbonate and 2 HCl's, for making sodium chloride, salt, CO2 gas, and water. The ingredients that I need to make the sodium chloride, the CO2, and the water are 1 mole of sodium carbonate and 2 moles of HCl. And if I combine those amounts, I will get 1 mole of water, 1 mole of CO2, and 2 moles of sodium chloride. Just like if I combine 1 slice of cheese, 2 slices of bread, 2 tomato slices, 1 slice of turkey, and 2 lettuce slices, I will get 1 turkey sandwich. The important thing to note about chemical reactions as recipes is that the quantities are always given in terms of moles. So if I know something about the mass of sodium carbonate that I start with, I cannot use this recipe until I change it into moles. Just like if I know how many heads of lettuce I have, I can't determine how many sandwiches I can make until I know how many leaves equal 1 head. So I need to know how many grams equal 1 mole if I want to use this recipe. That means whatever units I'm given for the amount of things that I start with or the amount of things I end up with, I have to change those units into moles. But luckily we already know how to do that, and so we can proceed. Let's start by doing an example that answers the question, how much can I make? So if I mix 10 milliliters of a 0.1 molar solution of sodium carbonate with excess, lots of HCl, how many moles of water are produced? So the first thing that we need to do, always, is to change the quantities of stuff that we start with, or stuff that we're given, into moles. And so we have a volume and a concentration because this sodium carbonate is a mixture. It's a solution of sodium carbonate in water. So we know how many moles of sodium carbonate there are per liter of solution, because that's what capital M means. I can figure out how many moles I have by recognizing that 0.1 moles of sodium carbonate are contained in 1 liter of solution, and I have 10 milliliters of solution. Furthermore, I know that there are 1,000 milliliters in 1 liter. And if I calculate this out, I will find that I have 0.001 moles of sodium carbonate that I'm starting with. Now, once I know that I have 0.001 moles of sodium carbonate, I can use my recipe, which tells me that every one of these gives me 1 water. So if I start with 2 of these, I get 2 of these. If I start with 1 of these, I get 1 of these. If I start with a half a mole of these, I get a half a mole of these. That means that if I start with 0.001 moles of sodium carbonate, I know that the recipe tells me that 1 mole of sodium carbonate is equivalent to 1 mole of water. And so I make an equal amount of water. My problem asked me to find the number of moles of water that are produced, and I have now the number of moles of water that are produced, and so that's the answer to my problem. So the first step is to change any quantities you have into moles, however you need to do that. And then the step 2 is to use your balanced equation or your recipe to figure out the equivalent number of moles for whatever other compound you're trying to determine the amount. We can go one step further and ask how many grams of water is this? And we know that the conversion between moles and mass is the molar mass. So remember that the molar mass is the mass per number of moles. So if I want the mass, then I just need to solve this equation for the mass, and the mass will equal the number of moles times the molar mass of the substance. The molar mass of water is 18 grams per mole, and so the mass of water that I produce is the number of moles of water times the molar mass of water, or 0.018 grams of water are produced. I might take this one step further and ask what the volume of water is that is produced. And if I know the density of water, which is 1 gram per milliliter, and I know how many grams of water that I've produced, I can calculate the volume of water, because density is equal to mass divided by volume, and therefore volume is equal to mass divided by density. And I know that I have produced 0.018 grams of water. Its density is 1.0 grams per milliliter, and therefore I have produced 0.018 milliliters of water. So the final step in this problem is to convert the moles that we calculated into whatever units are desired. So we converted it to grams, and then we converted it to volume or milliliters. So the basic steps in doing any how much do I need or how much can I make problem is to change any quantities you're given into moles, use the balanced equation to find the equivalent number of moles of whatever other compound you're interested in, and then convert that number of moles into the units that are desired or the units asked for in the problem. Let's do another problem to practice this. And in this case, we're going to ask, how much do I need if I want to make a certain amount of something else? Let's ask ourselves the question, if I want to make 0.1 grams of sodium chloride, how many grams of sodium carbonate should I start with? The first thing we need to do is to convert grams of sodium chloride into moles of sodium chloride. So I have 0.1 grams of sodium chloride, and I know that sodium chloride is 58.44 grams per mole. So 0.1 divided by 58.44 is equal to 0.0017 moles of sodium chloride. So I want to make 0.0017 moles of sodium chloride, and I want to know how many moles of how many grams of sodium carbonate do I need to make that amount of sodium chloride. So my next step is to use the balanced equation, or the recipe, to figure out how much sodium carbonate I would need. So I need to make 0.0017 moles of sodium chloride, and I know from the balanced equation that 2 moles of sodium chloride is equivalent to 1 mole of sodium carbonate. And so I have to divide this by 2 to figure out how many moles of sodium carbonate I want. And that is 0.00086 moles of sodium carbonate are needed. Now, I don't want moles of sodium carbonate, I want grams of sodium carbonate, and so I'm going to need to convert that to grams. So 0.00086 moles of sodium carbonate times the molar mass of sodium carbonate, which happens to be 106 grams per mole, will give me the grams of sodium carbonate that I need. So multiply by 106, I need 0.0907 grams of sodium carbonate to make the 0.1 gram of sodium chloride that I wanted to make.